Hello, this is the last problem of homework 5. Um, the uniform 18 kilogram rod AB is supported by a ball and socket joint at A and by the cord CG that is attached to the midpoint G of the rod shown in the figure. The rod leans against a frictionless vertical wall at B. So, the key terms right here are frictionless and the midpoint G. So, let's draw our free body diagram as always. We can see that A is at a point here that can rotate, but it can't move in any direction, so we'll have an AX. Sorry, that's an AY. This is AX, and this is AZ. We have our weight going down right here. We have tension. We'll label this TGC, like so. And because it's frictionless, there is no By force. There's only a Bx force because it's pointing opposite of the wall. And that's our free body diagram right there. So to find the tension in the cord, we are given, we can find the weight, which is equal to mg. Plugging in 18 kilograms times 9.81 meters per second squared, we get 176.6 newtons. We can also get the position vector from G to C as negative 300I plus 200J minus 225K. And we'll get that its magnitude is equal to, let me write it like this, from G to C is equal to 425 millimeters. So then we know that the tension GC is equal to T over 425, which is magnitude times its position vector. This is the same thing as its unit vector. I don't know why that happened. 200J minus 225K. And then we can also get our position vectors from A to B, which is equal to negative 600I plus 400J plus 150K. And then R from A to G. And the reason we're doing this is because we're going to take the moment about A to eliminate all those unknowns that we had. We have negative 300I. I don't know why this keeps happening. Plus 200J plus 75K millimeters. Now we can take the moment about A, crossing all our forces. So when we take the moment about A, we'll do it to the weight, to the tension. So we're going to use that position vector twice, and then to B. And using all that information right there, we'll take the moment about A and set it equal to 0, and that will give us enough information to solve for the tension, which is equal to 93.8 newtons, and B is equal to 132.4. And we know this is in the x direction or the I component, and that is the final problem.